You know that feeling when your workout gear just, well, feels right? It moves with you, it breathes, you hardly notice it's there.
Yeah, absolutely. Comfort is key.
But then picture adding technology to that, maybe tracking stats or helping recovery, even guiding your form.
Hmm.
Often, though, the tech we imagine feels separate.
Yeah,
A bulky gadget, maybe stiff pads or wires that just don't mesh with the fabric.
exactly.
Hmm.
It can be uncomfortable, definitely limits movement, and you probably wouldn't just toss it in the wash.
Right.
And that's actually a major hurdle for user adoption and making it work effectively in real-world fitness and wellness scenarios.
Okay.
A lot of current smart wearables or tech integrated into gear often relies on things like rigid printed circuit boards, PCBs,
Yeah.
or even flex PCBs, which are better but still somewhat limiting.
So they compromise comfort.
They can, yeah. They restrict movement, can create durability issues,
Yeah.
especially when you factor in sweat, washing.
Yeah.
It's tough.
Right, you want your gear to feel like a second skin, not some kind of science experiment strapped to you.
Precisely.
So the stack of sources you've brought us today takes a really fascinating deep dive into a technology that seems poised to change all that. It's about making smart textiles genuinely integrated and comfortable.
It is. We're talking about using something as, well, traditional as embroidery.
Embroidery, like stitching.
Exactly. Using embroidery to create these high-tech fabrics of the future, specifically for fitness and wellness applications.
Wow. That's quite a juxtaposition, an old craft powering new tech.
It's a really compelling bridge, isn't it, between an ancient technique and cutting-edge functionality.
Absolutely. So our mission in this deep dive is to unpack these sources you've shared. We want to understand exactly how embroidery is being used here, what specific applications it's enabling right now in fitness and recovery, and I guess what the potential is for a completely rethinking smart gear and equipment. It's about seeing how intricate stitching can actually power innovation.
And the sources really make a strong case for this functional embroidery being a genuine game changer, mainly because it directly tackles those limitations we just talked about, the problems with existing rigid tech.
How so? What are the core advantages that embroidery brings? Why is it better for embedding electronics in fabric?
Well, probably the most significant advantage highlighted is achieving full textile flexibility.
Okay.
When you integrate electronic pathways and components using embroidery, the fabric keeps its natural properties. It can still drape, stretch, bend, move naturally with your body or whatever structure it's part of.
That sounds critical for comfort, for wearability.
It really is. The tech doesn't feel like some add-on. It feels like it's part of the fabric itself.
Right. Makes sense.
And another major point is durability,
Yeah.
specifically washability.
Ah, yes. Crucial.
The sources discuss this being achievable, often with optional waterproofing depending on what it's used for. But think about athletic gear. It has to be washable.
Non-negotiable, absolutely.
This technology makes that possible, even with embedded electronics.
Okay, that's huge. What else stands out?
Complete textile integration, which means you can avoid embedding rigid components inside the product altogether.
So the electronics are literally built into the textile layers through the embroidery.
That's the idea. It gets closer to that smart textile ideal, where the fabric isn't just holding the tech, the fabric is the smart component, in a way.
I like that. The fabric is the component.
Yeah. And this also offers incredible design flexibility. Unlike, say, a rigid board with a fixed layout, embroidery lets you create flexible array geometries. You can precisely space elements like LEDs. You can make completely customized shapes and sizes tailored to specific body parts or unique product designs.
And it sounds like the manufacturing gets a boost too.
It does. The sources emphasize scalable production, and importantly, they mention the potential for automated integration steps.
Like what?
Things that might normally need separate assembly, like adding LED modules or creating complex electrode patterns with all their traces and connection points. Sometimes these can be done in a single automated embroidery step.
Wow. Streamlining production like that must have some serious economic benefits.
You'd think so. Reduces complexity, potentially cost.
And the range of products this tech can go into. You mentioned it's broad.
Oh, it's vast. The sources list everything from small items like cuffs, face masks, headbands, to larger things like full body mats, belts, bandages, regular garments. And this is interesting integration directly into fitness and rehabilitation machines themselves.
Okay, that covers a lot of ground. Let's maybe zoom in on some specific applications the sources highlight. One that really caught my eye was using embroidery for light therapy.
Right. This focuses on integrating LED arrays, light-emitting diodes, directly into textiles. for photobiomodulation.
Photobiomodulation, so like red light therapy.
Exactly. Think wearable red light therapy,
Yeah.
but integrated into a soft, flexible fabric.
Okay, so instead of sitting in front of a stiff panel, it could be like a wrap or a pad you wear while you move or rest?
Precisely. The sources mention the embroidery process works with various wavelengths, popular ones like red and near-infrared, or NIR, but also blue and others, so it allows for different therapeutic uses.
And the benefits of doing it this way, with embroidery.
Well, the key advantages really echo what we discussed generally about embroidered textiles. They're flexible, comfortable, reliable.
Makes sense.
For light therapy, this means you can have wearable applications, soft goods, therapeutic textiles that people are much more likely to actually use consistently because they aren't restrictive or awkward.
Better compliance, maybe?
Potentially, yes. And the ability to create flexible array geometries and control the LED spacing precisely means you can optimize the light delivery for specific areas or conditions. And critically, this tech is presented as ready for scale production.
So it could make light therapy more accessible, maybe more effective through better skin contact and targeting, and just more convenient for regular use.
That seems to be the promise. Now let's shift gears a bit to another really fascinating application, the source's detail. Electrodes. Specifically, what they call Moss-embroidered textile electrodes, sometimes called 3E electrodes.
Moss-embroidered. Okay, that name definitely sparks curiosity. But first, what's the problem they're trying to solve? What's wrong with current electrodes?
They're primarily tackling the limitations of conventional gel electrodes, the sticky pad.
Oh yeah, like for an ECG or muscle stimulator?
Exactly. ECG monitoring or EMS electrical muscle stimulation.
They can be pretty messy, right? And uncomfortable if you wear them for long. And they peel off if you move too much or sweat.
You've hit the key issues the sources highlight: messiness, the cost and hassle of assembling them for repeated use, and the fact that they limit the flexibility of whatever product they're stuck onto. These Moss electrodes aim to be a superior alternative.
Okay, so how do they improve things? What are the benefits?
A major one is high comfort, because they're integrated into soft, breathable textiles.
Ah, so no sticky gel.
Right. Which means you can potentially use them for much longer periods without the discomfort or the mess. And they're designed to provide reliable, stable signal acquisition for diagnostics.
Like measuring signals from the body, heart rate, muscle activity.
Correct. Or provide effective stimulation for therapy, like EMS or tendon-S. And just like with the LEDs, they offer full design freedom. You can embroider them into almost any shape or size needed.
Very customizable.
And scalable for mass production. The sources even point to economic pluses, like a lower bill of materials and fewer assembly steps compared to making and applying traditional gel electrodes.
Interesting. Okay, let's get back to that moss structure. What makes it special? Why moss?
Yeah, the sources explain it's a unique 3D structure. So instead of a flat surface, imagine more like a dense, flexible mat, like moss, I suppose.
Okay.
This 3D structure ensures a really large contact area with the skin, and it provides superior skin contact even on uneven body surfaces where a flat electrode might lift off or lose connection.
Ah, so it conforms better.
Exactly. It helps create a reliable interface for the signal transfer, but without needing that messy gel to fill in the gaps.
Got it. So are the electrodes themselves flexible?
Extremely. They're soft, flexible, they're part of the textile. And importantly, they can be used either dry or wet.
Dry or wet. So dry for maybe comfortable, everyday monitoring, and wet perhaps for higher conductivity during intense workouts or therapy sessions.
That's the idea, yeah, depending on the specific needs of the application. And yes, they are designed to be washable and durable. Though, like any technical textile, the sources are careful to emphasize that specific testing is always needed for the final product they're integrated into.
Makes sense. Standard practice.
Yeah.
And you mentioned a production advantage earlier.
Yes, this is where embroidery really seems to shine for making electrodes. The sources state that the electrodes themselves, plus the conductive traces the pathways that carry the signal, and even the connection points for external electronics, can often all be integrated in a single embroidery step.
Wow. One step.
Often, yes, which drastically reduces manufacturing complexity and potentially cost compared to the traditional multi-step processes of making electrodes, applying conductive layers, adding connectors.
That's a huge efficiency gain. And are they compatible with existing devices like the monitors or stimulators people already use?
Yes. The sources note they are designed to be compatible with existing EMS devices and standard monitoring or diagnostic equipment. They can be seamlessly embedded right into garments. Think compression wear, sports bras, headbands, or used as integrated patches.
Okay, let's break down the specific applications they detail for these Moss electrodes. What does this mean for diagnostics? Biosignal monitoring.
For biosignal monitoring, they can be used for things like electrocardiogram, ECG, for heart activity,
Right.
electromyography, EMG, for muscle activity,
Okay.
and electroencephalography, EEG, for brainwave monitoring.
So basically replacing those traditional sticky medical electrodes with comfortable fabric versions.
That's exactly it. Imagine an ECG chest strap for an athlete or a cardiac patient, but without those irritating sticky pads. Comfortable enough to wear for hours, maybe even days.
That would be amazing.
Or EMG sleeves or bands for monitoring muscle activation during physical therapy or strength training. Or even EEG headbands built into sleep masks or gear for focus training.
The user benefits seem pretty substantial there.
They really are. No sticky pads means they're much better for repeat and long-term use. Increased comfort means people are more likely to use them as prescribed, better compliance. And they're easier to use at home or in clinics. Plus, they can be easily integrated into everyday clothing items, making monitoring much more discreet and convenient.
That feels like a huge leap forward in user experience for both medical monitoring and performance tracking. What about the other side stimulation, like EMS or TNS?
Right, for electrical muscle stimulation, EMS, and transcutaneous electrical nerve stimulation, TENS, this tech allows for creating smarter cuffs, belts, maybe even full body suits.
Smarter how?
Well, the sources highlight that integrating the electrodes via embroidery leads to, again, that lower bill of materials and fewer assembly steps. For the user, you get improved comfort with soft, breathable textiles instead of sometimes harsh pads.
Definitely more comfortable.
Plus, you gain that ability to create custom electrode shapes. You can precisely tailor them for specific muscle groups or nerve pathways, which could potentially enhance the effectiveness of the stimulation.
Targeting specific areas more accurately.
Exactly. And optional features like moisture control fabrics or anti-slip materials can also be integrated right alongside the electrodes in the textile design.
So overall, more comfortable, potentially more effective, and maybe cheaper to manufacture Embroidery's gear. Didn't the sources also include some comparison data on performance?
They did, yes. They showed that these 3E, or Moss electrodes, perform comparably to conventional dry ECG chest straps during resting phases. So similar signal quality when you're still.
Okay, comparable at rest.
But, and here's where it gets really important for fitness and rehab, they are significantly less prone to motion artifacts during movement compared to those conventional dry straps.
Motion artifact, that's the noise, right? The interference you get in the signal when someone moves.
Exactly. That noise can make the data almost useless if you're trying to monitor someone during exercise or activity.
So these embroidered electrodes provide much cleaner, more reliable data when the body is actually moving.
That's the key finding highlighted. It means the data you collect during a workout or a physical therapy session is much more likely to be meaningful and actionable.
That's a really powerful advantage. Okay, so we've covered wearables, light therapy, electrodes, but you also mentioned integration into equipment. Let's shift gears and explore how embroidery is putting intelligence into smart fitness and rehab machines.
Right. The sources point out that expectations for modern gym or rehab equipment have really changed. Users don't just want passive machines anymore.
They want feedback, data.
Exactly. Real-time feedback, personalized guidance, quantifiable results. And the facilities themselves, gyms, clinics, sports performance centers, they want improved safety, ways to track performance progress objectively, and also to optimize how they use their expensive equipment.
Okay, so how does embroidered textile tech fit into that picture?
It allows intelligent sensors, feedback elements, to be integrated directly into the soft parts of the machines.
Like the upholstery.
Precisely. Think the seats, the backrests, the supports, anywhere the user directly interacts with the machine's surface. We're building the smarts right into those textile components.
Building the smarts into the furniture, essentially. What are the benefits for the person actually using the machine, the athlete or patient?
Well, this enables really personalized feedback. Things like your posture, your effort level, maybe even subtle cues about muscle activation patterns.
How so? Give me an example.
Okay, maybe the machine could tell you if your lower back is losing contact with the support pad when it shouldn't be, or if your weight distribution is uneven on the seat during a leg press.
I see. Real-time form correction.
Exactly. And that directly ties into injury prevention. It can alert you to incorrect movements, maybe overextending a joint, or using improper form that could lead to strain.
That could be huge for safety.
And beyond safety, receiving biofeedback And seeing visible progress through automatically tracked data can significantly boost motivation. It could even enable gamification, the machine giving you challenges or scores based on your form and effort.
That sounds way more engaging and safer than just lifting weights blindly. What about the flip side, for the facility owner, the clinic manager?
For them, integrating these sensors provides really valuable data. They can monitor machine utilization, see which machines get used most, and for how long. That helps optimize the gym layout or future equipment investments.
Makes sense from a business perspective.
Offering machines with this kind of built-in intelligent feedback also helps them stand out from competitors. It's a clear differentiator.
A unique selling proposition.
Right. And they can track client progress automatically. Having measurable data demonstrates improvement, which is especially valuable in rehab settings. All of this, the enhanced experience, the quantifiable progress, can significantly increase client engagement and retention.
So it's a win for the user and a win for the business. What kinds of sensors are actually being integrated using embroidery in this context?
The sources list several types. Pressure sensors are a big one.
Sure.
They can detect force distribution and weight. Crucial for assessing seating position or monitoring pressure points during exercise to ensure proper form or prevent discomfort.
Okay.
Then there are strain or stretch sensors. These measure the deformation of the fabric itself.
So the machine knows how far you're moving.
Exactly. It allows the machine to monitor range of motion, limb extension, or even subtle movements related to muscle activation or posture adjustments.
Clever. What else?
Touch or contact sensors. Simpler, perhaps. They just detect if a body part is in contact with a specific area. Useful for verifying correct posture, like making sure your back stays against the support.
A simple yes-no check.
Pretty much. And capacitive sensors. These can sense proximity or subtle changes even without direct, firm contact. Useful for more advanced posture tracking or maybe detecting the very initiation of a movement.
Okay, a range of sensing options. And how does the machine communicate this info back to the user? It's not just numbers on a screen.
Not necessarily. The sources also mention integrating interactive feedback and actuation elements directly into the textiles alongside the sensors.
Like what?
Things like small vibration motors embedded in the pads. They could provide tactile alerts, a gentle buzz if your posture slips, for instance.
Haptic feedback. Nice.
Heating elements, also embroidered and perhaps for warm-up before exercise or for recovery afterwards.
Built-in heat therapy?
LEDs or other light indicators directly on the machine surface. They could provide simple visual cues, maybe turn red if your form is wrong, green when it's correct.
Intuitive visual guidance.
And of course, integration with LCD screens or other displays to show real-time metrics, guidance, progress data, and so on.
It really is like building a silent, smart coach directly into the furniture of the gym or clinic.
That's a really good way to put it. And, beyond these major areas, the light therapy, the electrodes, the smart equipment integration, the sources also briefly touch on other innovations enabled by this functional embroidery technique.
Yeah. What other possibilities did they mention?
Well, they briefly highlight integrating heating elements, not just in equipment, but also into garments for, say, thermoregulation or muscle recovery wraps.
Okay.
They mentioned creating textile coils, using embroidery for things like magnetic field therapy or other advanced smart recovery applications.
Coils. Embroidered.
Apparently so. And really fascinatingly, they discuss integrating flexible tubing directly into textiles using embroidery techniques.
Tubing, like for liquids or air.
Exactly.
Yeah.
Allowing for flexible fluid transport within the fabric structure, for things like active cooling garments, or heating systems using fluids, or even compression therapies delivered through channels in the fabric.
Wow. Tubes stitched right into the fabric. That shows incredible versatility for embroidery.
It really does, and I think the key takeaway the sources keep reinforcing across all these different applications is that functional embroidery is powering these diverse, often complex electronic and even fluidic functions, and frequently it can be done in a single manufacturing step.
Leading to simpler, more integrated, and potentially more cost-effective solutions.
That's the argument.
So, pulling all of this together then, the core message from these sources really seems to be about this fundamental shift, moving away from traditional, rigid, often clunky electronics towards these fully textile integrated solutions.
Absolutely. It's about enhancing comfort, flexibility, washability for you, the user, making smart fitness and wellness tech something you might actually want to wear or interact with regularly.
It makes it more user-friendly.
Definitely. And it creates entirely new capabilities for athletes, for patients in rehab, and for the gyms and clinics that serve them. It enables more data-driven, personalized experiences. For manufacturers, it offers potential for improved durability and scalability.
And those economic benefits from streamlined production we talked about?
Right. It seems to benefit the whole ecosystem.
It's pretty remarkable, isn't it? To think that this ancient art, pushing a needle and thread through fabric, is becoming the key method for embedding cutting-edge sensors, LEDs, electrodes, even tiny tubes. It genuinely turns the textile itself into a functional component for performance, for recovery, for interacting intelligently with our bodies and equipment.
It really is a fascinating merging of worlds. The soft, adaptable nature of textiles combining with the precise, functional world of electronics and engineering.
Well, this deep dive into the sources you brought has certainly painted a very clear picture. Embroidered e-textiles aren't just some niche experiment anymore. They seem to represent a foundational shift in how smart technology gets integrated into the fitness and wellness landscape. Thank you for bringing these sources and walking us through them.
My pleasure. It's exciting stuff.
It really is. And for you, our listener, thinking about how embroidery is enabling these complex electronic and functional elements to be seamlessly woven, quite literally, into flexible fabrics. It makes you wonder, doesn't it? What other everyday items that we currently think of as purely textile, maybe your sofa, your office chair, maybe even your bed sheets, might soon become smart, thanks to this quiet textile revolution? Something to ponder until our next deep dive.